Good afternoon, everybody. I am Mahinder Kumar, Senior Lecturer, Civil Engineering from Government Polytechnic College, Batala. So, today I will interact with you on the topic of compass surveying from the very important subject of civil engineering surveying. So, this is the one of the quickest survey we have in our classification of surveying. So, chain survey is used when area to be surveyed is comparatively small and fairly level, but when the area is large with full details, the chain triangulation is not possible, but we do traversing, and that traversing is adopted in that case. In traversing, when compass is used for making angular measurements and length of the lines are measured by a chain or a tape, it is known as compass surveying. That is, in compass survey, we measure the length by a chain or a tape, and the angular measurements are measured with the help of a compass. In the compass survey, chaining and offsetting is done in the same way as in chain surveying. You must have read the very first one chapter of chain surveying. So, we do chaining and offsetting in the same way as we do in the chain surveying, but triangulation is not done. That is, we do not form triangles. Check lines and tie lines, you must have studied up till now. Check lines and tie lines are also not necessarily in compass surveying. Compass survey requires a lot of calculations to obtain included angles of the lines from the observed bearings, that is the bearings we observe in the field. It takes more time and is more expensive. That is, compass survey takes more time and is more expensive than the chain surveying. So, when we compare it with the chain survey, so compass survey is slightly expensive and time consuming. So, suitability. How compass survey is suitable? The compass survey is suitable, number 1, when the survey details are required along the long narrow strips. Which are long narrow strips? For example, a road is there, a railway line is there, or a canal stream is there. So, in that those cases, the compass survey is more suitable. Number 2, when the area cannot be divided into triangles, such as in towns or cities, that is, when we are unable to divide the areas into triangles, in that case we can do compass survey. Number 3 is when the ground is large open tract, that is, the area is very large with a few isolated noticeable features, that is, points to be plotted are very few and the area is very large, then we can perform compass survey. Number 4 is there when long straight lines and convenient tie lines cannot be drawn due to obstacles. That is, when the obstacles are there in the field or area to be surveyed and we cannot draw long straight lines or tie lines, then we can use compass survey. 5th is when surveying is done in jungles or in woody area or in dense forest is there, in that case also we can do compass survey when we have to survey in jungle or in dense forest. 6th is in a hilly country where chaining is tedious, that is, the chaining is tedious, in that case we can perform compass survey. So, when it is unsuitable, so unsuitability of the compass survey, the compass survey is unsuitable in places abounding in magnetic rock or iron ore, where there iron ore is present in the beneath the ground, that is in the abundance, magnetic rock or iron ore is there. In those areas we cannot perform compass survey, because in this we use a magnetic needle which will be attracted by the rock or iron ore. So, we cannot perform magnetic we cannot perform compass survey due to magnetic ore or iron ore. It is less accurate than the theodolite traversing, but can be performed rapidly. So, it has got an very important advantage that we can do the survey very quickly, that is we can perform the survey very rapidly. Therefore, it is generally suitable for rough surveys where accuracy is not important, where speed is main concern and not the accuracy is main consideration, such as in sketching and night marching for military purposes, etc. So, in those areas we can use the compass survey. So, we will study about the instrument. So, in this compass survey, when we use a prismatic compass as an instrument, so we will call it a compass survey. So, now we will study about the compass. A compass is a small instrument which consists essentially of a magnetic needle, a graduated circle and a line of sight. When the line of sight is directed towards a line, the magnetic needle points towards magnetic meridian and the angle which the line makes with the magnetic meridian is read at the graduated circle. The compass cannot measure the angle between the two lines directly. If it is desired to find out the angle between two lines, firstly their angles and then the difference of the two value is found, which is equal to the angle between the lines. So, there are two types of compasses. First is prismatic compass and the second is surveyor's compass. So, we will use only prismatic compass. So, on your monitor screen you will find the sectional view of the prismatic compass. Here on this sketch, digits are marked from 1 to 17 or so. So, and name of those digits are written below the section view of the instrument. For example, 1 is compass box, 2 is pivot, 3 is magnetic needle, 4 is graduated ring, 5 is agate cap and so on. So, please look at your monitor screen. So, about the construction of the prismatic compass, please look at the monitor screen of your computer. The prismatic compass, it is very valuable instrument and is commonly used for rough surveys where speed and not the accuracy is main considered. It was invented by Captain Catter in 1814. That is the name of the person who invented this prismatic compass is Captain Catter in the year of 1814. So, figure shows the sectional elevation of the prismatic compass. It consists of a cylindrical metal box marked as number 1 on your monitor screen of about 8 centimeter to 12 centimeter diameter, in the center of which is a pivot marked as 2 on your monitor screen, carrying a magnetic needle marked as 3 on your magnetic screen, which is already attached to the graduated aluminum ring. 4 with the help of a agate cap marked as 5 on your monitor screen, the ring is graduated to a half a degree, that is to 30 minutes and is read by a reflecting prism marked as 7, which is protected from dust, moisture, etc. by the prism cap, which is marked as 8 on your monitor screen. Diametrically opposite to the prism on your monitor screen is the object vane marked as 12, hinged to the box side and carrying a horsehair marked as 13, with which object in the field is bisected, that is we bisect the object with the horsehair. The eye is applied at the eye hole below the sighting slit marked as 9. Graduations on the ring can be observed directly by the eye after they are reflected from the diagonal of the prism. As a prism is there in the as you see on your monitor screen. So, it is called as a prismatic compass. The graduations can be made clearly visible by adjusting the prism to the eyesight by the focusing screw marked as 11 on your monitor screen. Both the horizontal and vertical side focus of the prism are made convex to give the magnified readings. To prevent undue wear of the pivot, the object vane is brought down on the face of the glass cover marked as 6 on your monitor screen, which presses against a lifting pin marked as 17 on your monitor screen, and the needle is then automatically lifted off the pivot by the lifting lever marked as 18 on your monitor screen. To damp the oscillations of the needle before taking a reading and to bring into rest quickly the light spring brake. As we have brakes on our 2-wheelers and 4-wheelers, we have also spring brake on the prismatic compass marked as 16 on your monitor screen, which are attached to the inside of the box is brought in contact with the edge of the ring by gently pressing inward the brake pin marked as 15 on your monitor screen. If the bearings of very high or very low objects are to be taken, the reflecting mirror marked as 14, please look at your monitor screen, which slides on the object vane is tilted and image obtained in it is bisected by the horse hair. A pair of colored glasses, as is seen on your monitor screen marked as 10, shall have to be interposed between the slit and the object vane when the sun or some other luminous object is to be bisected. A metal cover fits over the glass cover as the object vane when the compass is not in use to prevent it from dust or moisture, etc. So, how does the prismatic compass work? You have on your monitor screen the sectional view of the prismatic compass. How this prismatic compass works, we will study just now. So, working of the prismatic compass. The prismatic compass can be used while holding in hand, that is we can use it by holding it in our hand, but for better accuracy it is usually mounted on a light tripod stand, that is the stand which has got 3 legs, that is called as tripod stand. By means of a ball and socket arrangements, the compass can be placed in position easily. Its working involves following 3 steps. Number first is centering, number 2 leveling, and number 3 is observing the bearing or taking the readings. So, number 1 is centering. The center of the compass is placed vertically over the station point by dropping a small piece of stone below the center of the compass, so that it falls on the top of the peg marking that station. And in some compasses, facility of providing a thread with a plumb bob is there for accurate centering of the tripod stand or compass on the peg is also there. So, centering is done in this way. Number 2 is leveling by means of ball and socket arrangement. This is a special type of arrangements provided in the stand and the prismatic compass, which is called as ball and socket arrangement. The compass is then leveled so that the graduated ring swings quite freely. It may be tested by rolling around pencil on the top of the compass box. So, very important part of the working of the prismatic compass is observing the bearings or taking the readings. After centering the instrument over the station and leveling the instrument, raise or lower the prism until the graduations on the ring are clearly visible. When looked through the prism, turn the compass box until the ranging rod at the forward station is clearly visible. Use the brake pin and bring the ring at rest, and then take the readings at which the hairline appears to cut the graduated ring. So, with the compass, the sighting of the object and reading of the graduated ring are done simultaneously, that is at the same time. So, the reading which we take with the prismatic compass is called as bearing of a line. So, what is bearing of a line? It is the horizontal angle which a line makes with some reference direction known as a meridian. The reference direction may be any of the following three. Number first is a true meridian, number two is a magnetic meridian, and number three is a assumed meridian. So, true meridian, a true meridian of a place is a direction indicated by a imaginary circle, that is, if we assume an imaginary circle which passes as true bearing of line, it is also called as azimuth. So, on your monitor screen, this is the picture of north and south geographical poles we have. Please see to your monitor screen the picture of north and south geographical poles. So, true meridian at a station is invariable, that is, its direction is always same, direction remains the same always. So, second bearing meridian is magnetic meridian. Magnetic needle unaffected by local attractive forces is called as a magnetic meridian. So, this magnetic meridian is of great importance and most of the work we do is with this meridian. So, the direction indicated by a freely suspended and properly balanced magnetic needle unaffected by local attractive forces is called as magnetic meridian. The horizontal angle that a line makes with this meridian is called as a magnetic bearing of a line. So, please see on your monitor screen the diagram relating to the magnetic bearing of a line. And the third one, meridian is assumed or arbitrary meridian. So, for small surveys, any convenient direction may be taken as a meridian. It is usually the direction of a first line of survey or the direction from a station to some well defined permanent object. So, assumed and arbitrary bearing, what is that? The horizontal angle which a line and this meridian makes is called assumed or arbitrary bearing of the line. So, very important topic is designation of bearings. Just we have our names in our houses, pet names are there. Similarly, we designate the bearings. So, how we designate? There are two systems. First is whole circle bearing system and second is quadrantal bearing system. We will study one by one. So, designation of bearings, first system is whole circle bearings system. The horizontal angle which a line makes with the north direction of meridian measured in the clockwise direction. Please note it, it is clockwise direction and can value up to 360 degree, that is the whole circle. So, it is called as a whole circle bearing system of the line. It has value ranging from 0 to 360 degree. So, the prismatic compass measure the bearings of the lines in the whole circle bearing system. Second system is quadrantal bearing. As its name suggests, there are 4 quadrants. The horizontal angle which a line makes with the north and south direction of the meridian, whichever is nearer. So, please note it, north or south direction of the meridian, whichever is nearer the line measured clockwise or anti-clockwise direction towards the east or the west and can value up to 90 degree is, that is, one quadrant of the circle. So, is named as quadrantal bearing system of the designation of the bearings. So, third we have reduced bearing. What is that reduced bearing? The whole circle bearing when exceeds 90 degree, that is, when the value of a whole circle bearing exceeds, increases by 90 degree, may be reduced, that is, we reduce it or convert it into the corresponding bearings in the quadrantal system which has the same numerical values of the trigonometrical functions. The bearing thus obtained is known as the reduced bearing. So, there is a table which shows how we convert whole circle bearings into the corresponding reduced bearings. So, case 1 is there, if we have whole circle bearing between 0 to 90 degree. So, rule for reduced bearing, it is the same, or the quadrant in which it lies, north east quadrant, quadrant number 1. And if whole circle bearing lies between 90 degree to 180 degree, so rule is 180 degree minus whole circle bearing and the quadrant is southeast or second quadrant. Third case is 180 degree and 270 degree, whole circle bearing is in between 180 degree to 270 degree. So, reduced bearing will be whole circle bearing minus 180 degree and the line will be in the SW or third quadrant. Similarly, if the whole circle bearing is between 270 degree and 360 degree, then reduced bearing will be 180 degree minus whole circle bearing and quadrant will be northwest or fourth quadrant. So, this table shows how we can calculate whole circle bearing and reduced bearing. So, every line has got 2 bearings, one observed at each end of the line. So, what is fore bearing? The bearing of a line taken in the progress of the survey or in the forward direction is called as fore or forward bearing. Back bearing, the bearing of the line taken in the reverse or opposite direction is known as reverse bearing or back bearing of the line. So, the bearing of a line AB as shown on your meter screen expressed in the direction from A to B, that is observed at A by sighting towards B. Please see at your meter screen, it is fore bearing of AB. The bearing of AB when recorded in the opposite direction, that is from B to point A, is called as back bearing of AB. In the whole circle bearing system, fore and back bearing of a line, they differ exactly by 180 degree. So, formula is there, back bearing of a line is equal to fore bearing plus or minus 180 degree. We have to use plus sign if the given fore bearing is less than 180 degree and use minus sign if the fore bearing is exceeding 180 degree. So, please note this point, back bearing of a line can be found out by adding or minusing 180 degree to fore bearing. So, plus sign is to be used when fore bearing is less than 180 degree and minus sign is to be used when it exceeds 180 degree. So, in the quadrantal system, fore and back bearings are numerically equal. This is very important. but with opposite cardinal points. This N, E, W, S, these are known as cardinal points. Back bearing of a line may therefore be found in the quadrantal system by simply substituting N for S or S for N, E for W or W for E in the fore bearing system. Suppose fore bearing of a line is north 20 degree east, then to find out the back bearing, we are to replace N by S and E by west, W. So, it will be south 20 degree west. So, we have some numerical problem as shown on your monitor screen. Find the back bearings of the following observed for bearings of the line AB 53 degree 30 minutes, BC 112 degree 40 minutes, CD 201 degree 45 minutes, DE 317 degree 30 minutes. So, we know the formula back bearing is equal to fore bearing plus or minus 180 degree. In the first case, fore bearing is less than 180 degree. So, back bearing will be equal to 53 degree 30 minute. We have to add 180 degree and answer will be 233 degree 30 minute. In the second case, we have got fore bearing is equal to 112 degree 40 minute, which is again less than 180 degree. That is, we have to find out back bearing, which will be by adding 180 degree to it, and that comes out to be 290 degree 30 minute. In the third case, fore bearing is 201 degree 45 minute, which is more than 180 degree. To find out back bearing, we have to subtract 180 degree, which is equal to 21 degree 30 minutes. In the fourth case, fore bearing is 317 degree 45 minute, which is again more than 180 degree. So, to find out the back bearing, we have to deduct 180 degree. So, answer is 137 degree 30 minute. This is the example of whole circle bearing system. Again, an example is there. Following are the fore bearings of a line, find their back bearings. This is in the quadrant system. If the fore bearings of a line is given in the quadrant system, then the back bearing is numerically equal. This is very important to its fore bearing, but the letters of the cardinal directions are reversed, that is N for S or E for W and vice versa. So, in this case, we have fore bearing is equal to N north 27 degree 30 minute east. We will replace N by S and E by W. So, it will be south 27 degree 30 minute west very easily. So, second case, fore bearing south 43 degree 30 minute east, replace S by N and E by W, and back bearing will be north 43 degree 30 minute west. Similarly, in the third case, fore bearing is equal to south 17 degree 20 minute west, and we are to replace S by N, W by E to find out the back bearing of CD, which is equal to north 17 degree 20 minute east. So, similarly, fourth case, south 17 degree 20 minute east. Another example, convert the following whole circle bearing into reduced bearing. In this case, it will be very easy if we draw the sketches. So, or we can use the table which we have just seen. Whole circle bearing is 75 degree 30 minute, which is less than 90 degree. So, reduced bearing is equal to north 75 degree 30 minute east. This will become very easy if we use the diagram. In second case, whole circle bearing is 130 degree 20 minute, which is between 90 degree and 180 degree. So, reduced bearing comes out to be south 49 degree 40 minute east. Similarly, applying the rules given in the table 1, we are whole circle bearing is 235 degree 15 minute, which is between 270 degree and 360 degree. So, reduced bearing will be calculated by deducting 180 degree is equal to south 55 degree 15 minute west. Similarly, in the fourth case, it is north 16 degree 30 minute west. So, again another example is there, convert the following reduced bearing to whole circle bearings, north 47 degree 30 minute east, south 31 degree 20 minute east, third south 85 degree 30 minute east, and fourth is north 13 degree 10 minute west. So, to solve it, reduced bearing is 47